evaluate the integral 40 dx over 1 minus x squared raised to the 3 halves. So we can rewrite this just a little bit. Might be convenient to pull that 40 out front. And we could write this as dx over the square root of 1 minus x squared cubed. And the substitution to make here is to let x equal the sine of theta. Then the square root of 1 minus x squared would be the square root of 1 minus sine square theta, which would be equal to the square root of the cosine squared of theta, which would be equal to actually the absolute value of the cosine of theta. But what we're going to do here is we're going to say, well, let's let theta run between minus pi over 2 and pi over 2. Then we get that full range of minus 1 to 1 for the sine of theta. And over that interval from minus pi over 2 to pi over 2, the cosine is actually positive, so we don't need to worry about the absolute value there. Now, dx then would be cosine theta d theta. So if we take this integral now, 40 dx over the square root of 1 minus x squared cubed, we could actually write it as 40 times the integral of, okay, now dx. Well, we determined that to be cosine theta d theta. And then the square root of 1 minus x squared cubed, well, the square root of 1 minus x squared is just the same as cosine theta. So we can write that as cosine cubed theta. One of these cosines is going to cancel, so we're going to wind up with 40 1 over cosine square theta d theta. But we recognize 1 over cosine square theta to be secant square. So now we have 40 secant square theta d theta. Now we have this in a form that we can easily integrate because the antiderivative of secant square is tangent plus some constant. So we have 40 times tangent theta plus some constant. I don't really need to put this in parentheses because 40 times a constant is still a constant. Now, we were supposed to integrate 40 dx over 1 minus x squared to the 3 halves, so we're integrating with respect to x. I've got a function here that's in terms of theta. So what we're going to need to do is think, well, okay, how did this thing start out anyways? So we've got a triangle here, and we have an angle theta. We have a right triangle. And we said that the sine of theta was going to be x. So that's opposite over hypotenuse. X over 1 is x. That makes this side, using the Pythagorean theorem, 1 minus x squared. Okay, well then the tangent of theta is going to be opposite over adjacent. So that'll be x over the square root of 1 minus x squared. So now we have a way to write this expression in terms of x. And we're going to end up with 40x over the square root of 1 minus x squared plus some constant.